we're actually starting with the hybrid character of the conference, and we have the first online contribution by Nasimul Islam Maruf. Maruf is actually a PhD student at our university in Flensburg as well, and Maruf will tell us about one special thing. Modeling, yes, but it's modeling with open source, so that's important for looking into the details of what is inside the model, that you can understand why you derive certain results. Maruf will tell us about open models for highly renewable-based energy systems within the sector-coupled networks for the North Sea region. I hope, Maruf, you can hear me, and you have not quite the floor, but the screen in this case. Maruf, please.
Yes, I can hear. Can you hear me?
Yes, we hear you very loud and clear.
Okay. Thank you very much, Olaf. So Rafa was talking about the energy system models from a very continental perspective, and here I'm going to present open models, but from a sector coupled and also from the national and subnational perspectives. Hello, and I welcome you all to my presentation. My name is Nasimul Maruf, and I am from Europa University at Flensburg, Germany, and I'm also working at Fraunhofer ISE in Germany right now. Well, talking about models, you cannot predict the future, but you can model them and show the pathways, right? So this is what we did in the ENSYSTRA project, and I will try to show you some models I have worked on. First of all, the research question. So I did a thorough background study on sector coupling with a focus on the North Sea region from an energy system modeling perspective. I could identify that it is imperative to develop novel methodologies using comprehensive open modeling techniques and also applying cross-sectoral holistic approaches to analyze and investigate policy-relevant research questions for future highly renewable and sector-coupled energy systems. And also I identified that the methods should address both aggregated and disaggregated energy systems, because the subnational energy systems, they are often ignored. So it should range from subnational to national levels, and the openness of the model should enable the model users to use, modify, and upgrade the model for performing basic to advanced level of energy system analysis. So here are the research questions. Well, there are more, but I have just addressed two here. One is which state-of-the-art tools that are accessible to model the sector coupled energy systems, or you can say how you can actually choose an appropriate tool based on a specific rationales, and the most important, how to develop the methodologies for building open models for highly renewable energy systems in the North Sea countries. So how to utilize the models to investigate the policy relevant research questions from both subnational and national perspectives. And then we have because of the high essentiality for the open science required by the global energy system transition, I choose the idea of the open energy modeling to consider as the key criterion of the research. And then I did a preliminary list of state-of-the-art energy system models, combining some old researches. So I found like there are 80 plus state-of-the-art energy system models, but how many of them are open or free for academic use? There are 59. And then I selected some rationales for our North Sea case. And these rationales are like, it should have open modeling, renewable energy provision for maximum components, sector coupling, provisions. For example, it should have the heat and transport sector coupling provisions, energy storage provisions, and it should have the adaptability of different geographies, and it should have it should be able to do modeling of different time horizons, and also a little bit of grid modeling if possible. So with this rationales, the updated list of the open models, it narrowed down to 16, which I'm going to show you in the next slide. Yep. So I selected 16 models. I'm not saying that you have to select one of those models from this list, but I selected these from my rationales for this research, and I found then I So out of these 16, I also figured that there should be more rationales. For example, apart from the last 7, it should have, for example, net transfer capacity, top-down and bottom-up approach, etc. And based on that, I found out that I can use 2 tools. One is a PIPESA model and another is a WMOF. So out of these 2, I used WMOF for the open modeling techniques. And yeah, WMOF can actually significantly contribute to open science through its free and open software, collaborative development, and modular structural representation. And yeah, an investigation into the details of the WMOF and its application and usage suggests that it can include all the conventional and renewable generations of the North Sea energy system. But I also wanted it to be simpler, like it should have at least 2 levels, like a simple user can use it and model and see what happens in the energy system. So there is one option in WMOF, which is called WMOF Tabular. It is an interface to instantiate energy system models from tabular data sources based on the WMOF soft library. And the simple tabular data structure can be used for large energy system models, leveraging functionalities of the already widely used WMOF solve library. So in the figure left, you can see the concept of the WMOF network. There are sources, there are sinks and resource buses. For example, a source can be a PV or wind, and the sink can be electricity or heat load, and the buses can be electricity, heat, etc. And on the right side, you can see the example of heat pump modeling using WMOF tabular. So you can see that you do not have to go into the details of WMOF, but you can just use it from the tabular version, and you can provide your information, for example, different types of costs and where, from which bus it is coming from, to which bus it is going, etc. This kind of information. So in this way, you can do simplified modeling. And following that, I developed a model which is called Open Sector Coupled Energy Model, OSEEM. And yeah, the models, you can see that there are different volatile components such as onshore wind, offshore wind, solar PV, hydro run of the river plants. And for example, the fuel input of the CHP plant, it comes from the biomass resources. And in addition to CHPs, there are 2 types of heat pumps, air source and ground source heat pumps. There are storage options such as a pumped hydro storage, lithium-ion battery, vanadium redox flow battery, hydrogen, and adiabatic compressed air energy storage. Also, I explored a heat storage option, thermal energy storage using the hot water tanks. Well, the next part, I want to show you 2 case studies I did after developing the model. I'm not going into details of the model. It's a cost optimization model. And first, I selected a subnational region, which is Schleswig-Holstein in Germany. And here you can see some of the results. Well, Schleswig-Holstein is special because of its geographical conditions, because it has a lot of wind energy, and in Germany, it can actually provide a lot of wind energy to its neighboring areas. So, and also besides the biomass is one of the most significant shares. It has like 32.5% of share in Schleswig-Holstein, and it has the geological surface is suitable for storing large energy carriers such as hydrogen, synthetic methane, potential energy, thermal energy, etc. And in theory, the porous geological layers and the cavities in the subsurface can be used for storage as well, which is good for the CIES. So the OSEEM model, it analyzes the Schleswig-Holstein system for 3 different scenarios. I call it beam 25, 50, and 100, so depending upon different biomass penetrations. And yeah, the results, if I summarize, I found that onshore wind is invested to the maximum potential in one of the scenarios. However, with the increasing biomass penetration into the energy mix, we can see that the investment is not needed. And yeah, no additional offshore wind investment was needed in Schleswig-Holstein because it already had a lot of installed there. So we can easily export from that region to the other regions. Solar PV investment is maximum for the low biomass scenarios and minimum is in the high biomass scenario. Due to the cogeneration in a power heat coupled network, high biomass availability leads to increased investment in biomass-based CHPs. And also about heat pumps, high cost ground source heat pumps investment decreases in the scenario, and the low-cost air source heat pump investment increases when the CHPs increases. And electricity storages, if we look at it, they're used up to their maximum potential, except for hydrogen, which is used only in the low biomass scenario. And yeah, the use of hydrogen as an alternative storage is correlated with high cost volatile generator investments. The higher the volatile electricity, the greater the need for additional alternative storage. And yeah, thermal energy storage needs are the highest when the biomass availability is limited, indicating its maximum usage with high power to heat penetration into the system. I'm going into the next slide, which is a case study of Germany. And yep, in the German case study, you can see that I replicated the model and I analyzed the northern and southern Germany. And I analyzed it for 3 scenarios, namely base, conservative, and progressive. And the figures show the comparison of the energy mix results for the different scenarios. The total electricity generation in the base scenario is around 900, and it increases in the conservative and decreases in the progressive scenario to 800 around. And the progressive scenario yields a reduced heat generation with less heat demand. And I compared these results of this base and progressive scenario mix with a Fraunhofer ESR study, and it showed that like the ESR study showed that an 85% system is possible, but my model suggested that the remaining 15% is also possible with biomass-based CHPs, for example. But the system needs high electrification of the heating sector. This brings me to some final remarks. Yes, well, the good things, the model is novel and unique for the following reasons: that you can modify in 2 levels, the basic mode and the developer mode. It allows the creation of different scenarios. You can couple heat pumps with heat storages as dispatchable loads. And it's an open source model, which is definitely beneficial. It offers different storage provisions, and it considers different biomass potentials as well, from forest residues, livestock, agricultural residues, etc. And also, I claim that it is the first to analyze between northern and southern Germany, which is a very interesting topic in Germany right now. Other than that, yeah, there are some limitations as well. For example, I didn't do any transmission modeling. It was very simple. And I didn't consider the industrial heating demand. I didn't consider some of the renewable heating technologies. And yeah, there are possibility to include other storages and interconnection with neighboring countries. So all these things will update the model, and it will be better for the modelers or the users. Yeah, this was the last slide. Thank you very much.
Well, thank you very much, Maruf, and this worked fine.